Okay, so in this project, this lesson will help you calibrate a sensor. You've seen the previous one, we got a value for light or darkness range, and it depends how dark it gets or how bright it is, and your numbers will be slightly different. If you get a different photoresistor, it may react differently. It will give you different values based upon how it was built and what chemicals are in it and how it's actually manufactured. So, you know, it's something that varies greatly between different components. This is a neat little project, and this one here, it also uses, it says that there's two 10K resistors in here, and I eliminated those because I used the internal pull-up resistors again. So if you look this up on the Arduino site, I think I put a link in here. The original one, let's see if I can pull this up real quick. Do you guys see the Arduino site? Or is it still on the Tinkercode site? I'm having problems getting my cameras to switch. Did it pop up?
What?
Did it pop up the Arduino site?
Yeah.
Okay. I just want to show you real quickly. In this project here, notice they have one button, one photo sensor, photoresistor, has an LED, and then it has three resistors. The one resistor for the LED is automatically built into DuinoKit, but it's included here in the wiring diagram. And these two resistors you typically have to add in, and this goes if you use their code, which I took this almost identical from what they had. Notice they even show all the resistors and everything going into the schematic coming over here. But on ours, I went and pulled those out. So let me show you, it makes it a little bit easier. For some reason, one of the most underused component, you notice I don't need those resistors in here on the button. I don't need the resistor on the CDS cell. It just makes it easier to wire, although we have the same basic components to it. And that's because in the code, we changed a couple things. There's a schematic that I made for it, just to make it a little bit easier, I think. In this code itself, it does quite a few things. There's some credentials up here, where it came from and what it does and all that neat sort of thing. I did put a note in here that these resistors are optional. One thing that is good to have when you do proper coding is wiring instructions, because if you pull out this code, you go, yeah, how did I build that again? You're probably not going to find the tutorial page that it came from or remember how you built it. So we want to include wiring instructions in there. And some of the wiring instruction is included in the constants in the beginning. So I put a note in here that these resistors were optional, and we actually eliminated them because we changed the code slightly. So with that being said, let me show you what this value does, or what this code does. It sets up a button when you press it. And what it will do is it will read the sensor for a minimum and maximum value. So you can go through the range. For example, with the photoresistor, you'll make it light, you'll make it dark, and it will determine, hey, this is the maximum value from 100 to 500, or 50 to 300, or whatever it is, and determine this is my minimum value and the maximum value that I'm going to use. And it does that in, I'll show you here, you got your void set up. This just declares your pin modes. The input, I put it as an input pull-up. That allowed me to eliminate those other resistors that are on the breadboard, so I put it as a pull-up resistor. And then our loop over here, now this gets a little bit confusing because of the way it's written. As a matter of fact, one of your missions is to clean up this code a little bit. In other words, to take some of the comments and put it on the line that it belongs to. For example, up here, here's my command, and here's my command line here, and here's the explanation of what it's doing. So I think it's more convenient if you put them on the same line instead of putting one line for the comment, one line for the code, one line for the comment, one line for the code. It just makes it look larger, and it's also more confusing to see it. So one of your missions will be to clean up the code and try and condense it a little bit because this bottom half just looks a little bit crazy. It's hard to figure out what's going on. What I want to call your attention to is this little loop statement here. It's a while loop, which means it's conditional based upon this. If this button is low, in other words, if you're pressing the button, you're holding it down, it's going to call this function. That function is down here. You notice we got the setup, we got the loop. Well, we have another function down here called Calibrate. And what that's going to do is it's going to read the sensor pin. It's actually going to light up the indicator LED. That's on number 13, pin 13. It's going to read the sensor value, and it's going to find out, is this a maximum value or a minimum value, and then set it. And then it's going to do the same thing here. If the sensor value is less than sensor minimum, set it as your sensor minimum, and it's going to record a minimum maximum setting for your current sensor. This came in convenient, and I'll try and show you more probably on the next time we meet, on a project that I did using this same idea and using it actually on the photo sensor itself. And this is just a way to kind of calibrate and get your values that you want to work with. One thing that's not included in here is a way to view what it's doing. You're not going to know what it's doing. You're not going to see anything because there's no output. So I'd like you to put in probably a serial print so you can see kind of what's happening in the serial port, and that's going to be one of your challenges to see what it's doing. Otherwise, you press the button, the light lights up, and you really don't know what this program is doing in your Arduino. Another thing that is new in here is, let me find it. It's not in the Calibrate mode. It's down here. Well, here's our map value. Our map value, sensor value, the minimum, maximum, we want to range it from 0 to 255. So that would be our resolution of what we're looking at. So no matter what we get for a minimum or maximum, we're going to scale it to 0 to 255. And that's with that mapping sensor. It's a linear function that aligns those together. But I thought this one was neat. They just kind of threw in here, and we've never used it yet. It's a function called Constrain. This is actually a system function, and the reason I know that, or the way I know that's a system function, is we can put Constrain in here and enter our values, and we don't have to program it here. This is a user-defined function to calibrate, to take the minimum maximum setting, and we had to write that function in here to tell it what to do. Just like loop and setup are a system-defined function, so is the constrain function. And what it says is take your sensor value from 0 to 255, which came from up here, and keep it within that range. In other words, if your sensor then picks up, let's say it worked from 100 to 300, and you set it to go from 0 to 255, well, if it bumped up to 350 all of a sudden, it would bump up this maximum value as well. It would just give those 2 points to line them up, but then your maximum value would go higher. So this constrain function says, keep this value always between this and this. So it's going to keep it in that parameter so it will never go higher than that. That can be important a lot when you're dealing with numbers. If you accidentally enter a 0 and you divide by 0 and your microprocessor starts overheating and getting mad because it's doing illegal math functions. So sometimes you want to constrain your answers to certain things, and that is a system function that will help you do that. And what I'd like you to do, once we have the code and everything in there, is you got your 3 missions, and that's going to include cleaning this up a little bit. Easiest way to do that is to take your comment here. Oops, I can't copy and paste that because I can't edit it. Take this and put it at the end of the line that it affects. So put it on this line here. So whatever the line does, put the comment on there, and it will look a little bit cleaner, and you can kind of compare the top part of this code. Looks a lot more organized and a lot cleaner than the bottom part of the code. It's hard to figure out what are the commands and what are the comments, and it's just kind of, it doesn't look as nice. So one of the things we'll do is clean up the code. The other thing we'll do is display the values. either in your serial monitor or your LCD. If you have your LCD already hooked up, it might be easier to add that in. Otherwise, the serial monitor, just so you know kind of what it's doing, and that will get you a little bit more familiarity with the code and how it's operating. The one other thing that I put in there as a challenge is somewhere in this big program of code is there's a mistake where it will not compile. So if you copy and paste it and it doesn't compile, you did everything right. So now you have to figure out why it won't compile. So there is an error in there somewhere.
Oh, I already found that.
So, yeah, fix that error. That'll be your first challenge.
I thought that was like, because you did that before.
The other one, yeah. It's a real common error, and
I thought you left it out on like just because of the.
No, that's one that I usually do leave out.
Yeah.
So, yeah, I did do it intentional this time.
Sure.
But that, I don't want you to get too frustrated. Like, it doesn't work. It's like, okay, why? One of the things about finding code online is there's often, brackets missing, or, variables aren't declared, or a library that's missing. We haven't gotten into libraries yet. But things can, it can make things really confusing if you don't know exactly what to do. So I will let you guys build this project. It's pretty simple. You only need a couple wires. The resistor that's in the schematic and on this breadboard diagram is already built into the DuinoKit, so you don't need that as a separate part. So really you're hooking up an LED, button, and your photo sensor. And we're also using the onboard LED so you can see what it's doing. And I will let you guys work on that and work through your challenges, and there is of course a couple quiz questions after that. So take the quiz, make sure we get the scores on there, and let's see how that goes. And then I'll show you an application to this next time we meet some project that I wrote. Well, actually, it might wait a little bit longer because we have to cover the time clock as well. But I just thought this was a great snippet of code to have. One thing I do want you to do is start saving this code. When you go through all the effort to create this code and modify the code, and you have it compiling and everything's perfect and beautiful, save it with a descriptive name. For something like this, I would be putting Calibrate an Analog Sensor by the push of a button or something, so you know what the snippet does, because when you have to use this in something later, it's really nice to pull it out if you call it, sketch of the day. Hey, this is a program that I thought was pretty cool. You don't know what that name was, but you're going to want to pull these little things together to make larger projects. So start building your code library. And that's actually one of your assignments. If you are missing some things, I'm going through and trying to put in some of this code as we go along. I'm also trying to add in some other stuff that's interesting. So, for example, at the bottom of Unit 1, if I can get there, I have Unit 1 code and bonus sketches. So, I tried to compile all of the code. I might be missing a few things and I'll update it, but these are the things we did: blinking LED, breathing LED, flowing LED, toggling LED, LED and a button. We did turn signals. So the code is actually in here, so if you click on these, hey, look at that. I got some code, wiring directions, that's where it's nice. But I actually saved this somewhere, so actually have the file, save it on your Google Drive, and that way when you need these things, when you're trying to, how did I use a button again? Oh yeah, I did that, turn LED on and off. This one was one that we never talked about. Blinking LED without the delay function, because the delay function actually stops the program, so you can build it with a timer. There's sometimes stuff in there. And I'll try and throw in some extra software as well. If we look at Unit 2, I don't have it completely built out yet at this time, but I'll try and summarize all of the code at the end of the unit to include what we've been doing. So Lesson 2, lessons and bonus sketches. Calibrate sensor, yeah, I didn't put anything bonus in there yet, but it's got the LCD, it's got the volume level, the photoresistor, the alarm, and this one will be the Calibrate the Analog Sensor. So software is in there. I'll try and keep it in a file of this nature, and we'll update as we go along. But you should also be saving all of these with a meaningful name so they make sense. So start building your code library.